Okay, so in this video I'm going to be going over problem 1 from homework 3. So this problem involves the function f of x equals x to the power p, and we're asked to determine properties of the derivative at 0, specifically to find the value of the derivative at 0 if p equals 1 or p is greater than 1, and to show that it's not differentiable if p is less than 1. So the first thing to recall is that we do know a derivative of this function by the power rule is px to the p minus 1. Now, if p is less than 1, this power will be negative, and so that means that this formula is invalid in some sense, or it gives an undefined answer at 0 if we plug in 0. So that means that we have to go back to the definition of the derivative to determine what's going on. Is this a problem with the power rule where it's just giving us an undefined answer, or is it really the case that the derivative shouldn't be defined there, or the function is not differentiable there? So let's take a look at our definition of derivative at 0. So we have the limit as h goes to 0, f of 0 plus h, which is just h, minus f of 0 divided by h. So f of 0, well, I guess there's two cases. So if p is a negative power, then f of 0 is actually not defined. So in that case, of course, the function is discontinuous and not differentiable. So let's consider the case where p is between 0 and 1. So this is equal to if 0 is less than p, well, right now we don't have to say anything other than that p has to be positive. Then f of 0 is equal to 0. So we get h to the p over h, which is the limit as h goes to 0, h to the power p minus 1. So let's think about what happens here. If 0 is less than p is less than 1, then we have a negative exponent here. So this thing will look like a limit of as h goes to 0 of 1 divided by h to some power. And so that means we're dividing by smaller and smaller numbers, so the limit goes to plus or minus infinity in that case. And so therefore the limit does not exist. And that means that the function is not differentiable at 0. If, let's see, p is equal to 1, then we get the limit as h goes to 0 of h to the 0, which is the limit as h goes to 0 of 1, which is of course equal to 1. This makes sense because if p is equal to 1, we just said f of x equals x. It's a straight line with slope 1. We know its derivative is 1. If p is greater than 1, then we get limit as h goes to 0, h to the p minus 1. This is now a positive exponent, so if we have h to some power, and it's a continuous function if the exponent is positive, so we can just plug in h equals 0, and we'll get 0. So if p is greater than 1, we can say the function has derivative 0. If p equals 1, the derivative is 1, and otherwise the function is not differentiable.